on Highway 20, about 2 miles out. It's called the Museum of the Fur Trade. And they show you all the explorers that came and made trade with the Indians, how they provided guns. They have an excellent gun exhibit of all the old firearms, rifles and shotguns, clothing, tools.
Okay, we're on page 202. And we'll look at those problems. Number 2. And it says suppose triangle D E F congruent to triangle J K L, and then the 6 pairs of adjacent parts. Now what you have to do is you just got to make sure that you line them up. The side D E then is going to be congruent to J K.
Is this one the side of equal?
Yeah, it's the side. So what you have to do is you have to make sure that the D, E, F are the vertices that correspond to J, K, L. So then when you make those congruencies, you've got to make sure that they match up. See, EF would be KL on the side congruent, and then FD on the first triangle would be congruent to LJ. And then the other ones is the angle D would be congruent, and its corresponding angle in the other triangle is angle J. And angle E corresponds to angle K. And angle F corresponds then to angle L. It's only to show that you have to make sure that you write them right, so they correspond. So 4. So that number 4, it says, for the pair of triangles shown, write the appropriate congruent statement. Be careful about the order in which you list the vertices. So that this is a pair of congruent triangles. So all it is about is that you, wherever you start, like if you started on the first triangle and went STR, congruent to, then the vertice S would correspond to the vertice E. So then you would do E, and then T and G would correspond, so it would be E, G, F. And it just, you have to write it correctly, vertice by vertice in correspondence. And that's all that point of that problem is. So then 5 through 18, it says decide whether the pair of triangles is necessarily congruent. If so, write the appropriate congruent statement. Specify which congruent principle applies. Be careful not to make any assumptions about triangles that just appear to be congruent. So 6. By the way,
So that was the whole answer for number 4?
yeah. It will, yeah, it will not make, I mean, you could have this listed as STR EGF, or you could have it listed as TRS congruent to triangle GFE, or you could list it as RST congruent to triangle FEG. The point is that you have to make sure that, you know, point by point they match. That's all the point of that problem is. So 6, and it says, so decide whether the pair of triangles is necessarily congruent. Now in 6, what they have is they have this and then they're showing, well, let's see, they get this one G, H, I, this one K, L, J. And then they show this angle congruent to this angle, this side congruent to this side, and this side congruent to this side. Now you may or may not be able to say they're congruent. So the question is, are they congruent or not? Can you specify?
I don't know. Since they have, I guess, I think HI is equal to JF. And the other side is.
Let's see, I mean, you have for congruency, you got side, 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 angle, side, angle. And then you got right triangles where you'd be able to say two sides of a right triangle congruent, then it's congruent, and so on. But this is not a right triangle, so none of those specify. Is there any way to say they're congruent? And the answer is no. You cannot say they're congruent. So you cannot say because all it has is two sides of an angle, and that does not, it's an included angle. So you can't get a third angle. You know, there's no way to prove congruency in that thing. So no conclusion.
I guess that's something for number 8.
What's that?
It should be the same thing for number 8.
STU
Equilateral triangle.
V. So they're showing you that this one's congruent to this. This one congruent to this one. And then this one to this one. So can you make a conclusion? And
Seems to me it's just a reflection.
Yeah.
well, I mean, there's rules in the section. If you have three sides congruent to three sides, then it's congruent. The congruency is, now what you want to do is be sure if I put triangle S, U, T is congruent, now you want to specify it,
UWX.
yeah, UWX. And that's for the reason of side, side, side.
EWX, I'm sorry.
Is
EWX.
it a V?
My mistake.
So you want to make sure you specify the vertices corresponding, and then you want to be able to say why, what's the reason for it. So pen, what they have is they just have two triangles, but and then here what they have this one is congruent to this one is congruent to this one, let's see, and this one. So they got four of them congruent, and then the other two are congruent. So can you make a conclusion?
You know, almost something like Russian.
Yeah, the angles all match.
But because the angles match, you can do similar triangles. I mean, basically what you can do, it doesn't show congruency because this is
Right, it could be a much larger triangle.
what,
Doesn't
what
account for the sides.
if you do, this is how you can kind of show it. If you make parallel lines to that base, to see that what you can show is that this angle, and this angle are saying this one, and this one are the same, but they're not congruent.
Gotcha.
So just having all the angles, and this one's congruent to itself, so you can't say that three angles being congruent says anything about congruency of the triangles.
So no side equal.
Oh, you can't, this one here, you can make no conclusion. No conclusion possible.
That's the response you want, no
Yeah.
conclusion, not
Yeah.
congruent?
Yeah,
Okay,
but you can't say they're not congruent.
right.
You can just say you can't conclude anything. They could be congruent, but they don't have to be. Okay, 12. So what we have. Okay, so they're saying that this is P, this is R, S, and Q. And they're saying this side and this side are congruent. That side and that are congruent. So what you can do is you can prove they're congruent. And what you would do is you'd say the line RS is congruent to line RQ, and that's given. Then you can say that PQ is congruent to PS, and that's given to you. And then you could say PR is congruent to PR, and that's reflexive property. And then you would say therefore, the triangle PRQ is congruent to triangle PRS by side, side, side. Three sides congruent to three sides. And what I want to do is I want to have this have a reason here and then a statement here. So every statement should have a reason. But that's the way you could do that one, show congruency.
Oh, you see a statement? Like,
What?
what are those supposed to be? Those S's.
Which?
Those S's on the bottom of the,
Oh, this is side, side,
Oh, okay.
side. And that means their corresponding sides are congruent. And it's, it's one of the theorems that are stated, like on page 200, it said side, side, side congruency. And that's postulate 4.3 on page 201, congruent postulate. If three sides of one triangle are congruent respectively to three sides of another triangle, then the two triangles are congruent. And it's just shorthand saying side, side, side. Okay, 14. No way would I say that this is any kind of perspective. So they're saying this side is congruent to this side. This one is congruent to this one. And this angle right here is congruent to this angle. Now obviously side, side, side don't work. You got two sides and an angle, but what you have to have is you have to have two sides and an included angle. You have to have side, angle, side. Well, this one, this triangle right here, has a side, angle, side, but this one does not have a side angle side. It got two sides on an angle. So you can't make a conclusion. There's no way you can get another angle out of that thing that's equal, or another side out of it that is, congruent. So you can't make a conclusion. So we got this side are congruent. This angle are congruent. D. They're saying this one and this one are congruent.
I guess you can see side angle side, right?
Yeah, you got side angle side, so you show congruent. So what you would do is you'd say number one, AB congruent to, and it would be CD, that's a given. And then AD congruent to CE, given. And then angle A is congruent to angle C. And then you'd say the three little dots are therefore, and then you could go triangle D A B.
Is that angle or cake? Number 3, that's angle?
What? Is congruent to triangle EC, and that would be side angle side. Side angle side.
So then why wasn't 6, why were we able to conclude number 6? We had two sides on an angle. Pardon me?
Yeah. Yeah. See, this thing is side angle. It's got to be side angle side. This is a non-included angle. See,
Oh, you mean the angle must be between the two congruent sides?
That's right.
Gotcha.
Yeah.
Gotcha. Thank you, gentlemen.
There are some, if you have a right triangle where you're given two sides and an angle congruent in a right triangle, that you can. This one? 18. Hmm. That all looks good. Not quite perspective. So this side are congruent. This angle here, that angle congruent. And then we have P, Q, R, and S and T. And it's not, it's just saying the instructions are decide whether a pair of triangles are necessarily congruent. If so, write the appropriate congruent statement and specify which congruent principle applies. Be careful not to assume something that isn't there. Now, what you can do is if you consider the triangle that has P, T, S, I'll just kind of draw one side. And then this triangle that has P, this one. You can prove congruency by saying that number one, PT is congruent to RS, and that's given. And then you can say that
TS reflective.
I'm going to do angle PTS is congruent to RST.
That sine is triangle, right?
Yeah. And that's given. And then, like you said, Vince, what this is, you can say the line PS is congruent to the line ST, and that's reflexive.
So we need two sides of an angle.
Yeah.
Absolutely.
And then the triangle PTS is congruent to the triangle RST, and that's side, angle, side. This is supposed to be a therefore. But be sure that, to be really accurate, you should say, this is important to say, is that this side should be listed as TS, and this side should be listed as ST, because, that's the way they go around. And then make sure that you list triangles, the congruency, so the vertices match in the order that these things, that this and this vertice match, this vertice right here, and this vertice right here match, and then this one right here, and this one match. Because if you don't, technically it's wrong. So order is going to be important. It's not just seeing it and then just stating it anyway. It's all of those things have to be done correctly. Okay. So, like on a quiz, that's what I'm gonna be looking for. It has to be stated right. You know, the lines are gonna have to be stated correctly to match. You know, for example, in this problem, if I were to give it to you, and you were to say TS is equal to TS, that's not right.
Oh, okay.
It's TS is equal to ST, is congruent. You know, and if you had triangle PTS and you had STR, that's not right. You know, the vertices on that triangle, it's got to match. So I'm gonna be looking for that, all of that stuff. So 20. Now it says this says two pairs of triangles are congruent in the figure. Give both of them and state which congruent principles apply. So I'm gonna give a shot at drawing this thing.
This is side angle.
Try to get some points of reference. No. So it's A, B, C, D, E. So there's this one, and this one. This one, and that one. Okay. And then we got this angle
You know, side.
and this angle. So if you consider the triangle ABI and GFH, that's the one we're going to consider congruent first. So we're going to make the statements. Number one. AB and congruent to GF. And that's given. Added to AI is congruent
Does it
to
matter where you start?
GH. What?
Does it matter where you start?
What?
Does it matter where you start? Because can you start from can you start from ACH is congruent to IEG. Can you start from there? Like,
ACH.
Yeah, you can start from there, Toby.
Yeah,
It's a
you
different
could.
set of triangles.
Yeah.
okay, I'm just.
That'd be fine if you wanted to do that. But I think, yeah, you could, okay. This is given. And then 3, angle A is congruent to angle G. Now sometimes you can use the vertice point as the angle, but sometimes, like I did back here, you have to specify the angle, like this number 2 right here. You couldn't use the angle at T because there's 2 angles here at T, so you gotta specify it.
So if you
But
use
this one, I can just use A and G because the point, there's only one angle at that point. So don't, be sure that when you're specifying an angle, and I'm gonna go back to the previous one, don't call this angle T and angle S, because there's 2 angles up there, and you don't know which one you're talking about. Then you're gonna have to use a 3-point angle specification.
and the angle you're talking about has to be in the middle, right?
Yeah, it's gotta be, you can't just say T because there's this angle here, and there's this angle, and there's this angle here, and this angle at S. You have to specify it in a 3-point position. But this one, when I say angle A, there's one angle at A and one angle at G. That's my point that I'm trying to say. You can use a single vertice as an angle designation sometimes, but not always.
Now, Professor, on the next step, is it okay to specify the triangles in a different manner as long as they match each other?
As long as the points match each other around. So you're ready to say congruency, so you can then say therefore the triangle, and what do you think?
I've got ABI, but it could also
Okay.
be AI.
Yeah, ABI. Now what would be important?
GFH.
Triangle. Yeah, GFH.
As long as they match the other.
And this would be side angle side. Side angle side. So that's one triangle. Now, Toby, you said the other triangle. What you wanted to do is you were talking about this triangle here,
Yeah.
Mm-hmm.
and then this triangle right here. Okay. Now, in order to do that, what you're going to have to do is, I'll just go on to read, assuming that the rest of it just applies, right? 1, 2, 3, 4. I got therefore one triangle. Now I can say 5. I need additional information to do that. So what do I have to do? If you're going to do that one.
Well, you're going to need line BC is congruent to FE.
Okay.
Yeah. Well, you can use AC though. And GF,
That's given to you.
right? Can you use AC and GF too?
You could use AC now that BC has been established, Toby, you understand? You have to establish that, read that statement first.
Oh, okay. Because AB has been established. Okay, I got you. You know what you're saying?
Because now that we know AB is congruent to GF and BC is congruent to FE, now you can say AC and
Yeah.
GE for
Now
sure.
you could say AC is equal to AB
So
plus BC, right?
You can.
when do you know when to stop then? Because this one is long. Like when do you know when to stop? Or you just have to keep looking for all your angle possibly.
Yes, but we don't need to show step 6, do we?
Technically, you would.
Okay, gotcha.
I mean, what you'd say since this is true, and um,
That's NC now, lowest owners.
and then let's see, I got AC, so I would want to go GE is equal to, don't make any difference, GF plus FE, and that's, I'm not sure what you'd use for a, I think you'd just be a substitution.
What is that? When you write in front of AC, what is that?
Oh, since, I just wrote since. Since AC is equal to AB plus BC and GE is equal to GF plus CF, then what you can do is then you could say that 7 AC is congruent to GE. And this would be a transitive property. Because what you're doing is you're saying AC is equal to AB plus BC, and then AB is congruent to GF and BC is congruent to FE, and then that's true, then therefore it's, equal to GE. We're using a transitivity situation.
Transitive.
Now you have to establish what else.
GH and AI.
Yeah, you'd have to say the line IH is congruent to the line HI, and that's a reflexive property.
This one is equal.
And then you'd say it follows that AH equals AI plus IH, and GI equals GH plus HI and then I would just go AH, make sure that AH and GI. And that's some transitivity. And then you can make the conclusion that the triangle.
What is the last one?
What?
The last one you have there.
AHC is congruent to GIE. AHC GIE. show them is we've got the two triangles. This one and the triangle back up here. The one I didn't write the statement of Y, side angle side.
So, like, in the sense, it is like equal to specify the line you're talking about before going around about the triangle, right?
How's that?
It's better to show what's to go by line first before you go like around the triangle. So like, you understand what I'm saying? Like you show your steps step by step. You use lines and lines before you conclude the triangle.
Yeah.
It's better to go that way than going around about the triangle. You get what I'm saying?
Not 100%.
What I'm saying is like
I'm
it's
going
better-
to shut this down because we'll quit there.
what I'm saying is it's better to go like to